Good morning, all the Form 4 students. Today we'll study speed time. Why we study this chapter? This is because knowledge about motion is important in the automotive field, sports science, physics, engineering, and astronomy. Interpret speed time graph. Form 4 YouTube lesson number 3. Study the speed time graph below. The interpretation of the speed time graph. Speed increases. Now we focus to the pink color region for line PQ. The speed of object increases from u meter per second to v meter per second. Example u is 5 and then v is 10 meter per second. So the gradient of graph is positive, hence the rate of change of speed is positive. So acceleration is equal to change of speed over change of time. This means that the gradient of the line represents acceleration, and the area of trapezium A, that is the area under the graph PQ, represents the distance traveled in the period of t1 second. Now let's look at the area in green color zone. For QR, area under the line QR is actually distance. There's no change of the speed, so it's zero gradient. So the object moves at a uniform speed. The object didn't stop. The object still moving, but at the uniform speed, meaning that it moves with 20 meter per second. Alright, maintain the speed. Then the area of rectangle B, for the green rectangle B, that is the area under graph QR, represents the distance traveled in the period of t2 minus t1 second. Example, if t1 is 5 and t2 is 10, that means the difference is 10 minus 5, which is 5 seconds. Meaning that for the 5 seconds, the particle or the car is moving at uniform speed. Please do not have the wrong concept that the particle is stopped. It never stopped. It moves at a uniform speed. Now let's look at the region with the triangle shape, which is in orange color. Deceleration. So the speed of the object decreases. The gradient of graph is negative. Hence, the rate of change of speed is negative. Deceleration is equal to change of speed over change in time. There's no change in the direction. That is, the motion of object remains in the same directions. The area of triangle C, that is the area under graph RS, represents the distance traveled in the period of t3 minus t2 seconds. Example 1. Mr. Daniel Wong drive his car to a convenience store to buy newspapers. The speed time graph shows the motion of the car from his house to the road junction before reaching his destination. A. Okay, we're going to discuss A. Describe the motion of Mr. Daniel Wong's car for the first 10 seconds. Okay, as you can see, the first 10 seconds highlighted in green color line. So if you find the rate of change of speed for the first 10 seconds, that means you find the gradient. First of all, if you want to find rate of change of speed, you need to label the point on the line OA, green color line. So the O is origin 0, 0, and the A is 10, 25. Okay, so by using the formula of gradient, M equal to y2 minus y1 over x2 minus x1. So substitute y2 is 25, y1 is 0, and x2 is 10, x1 is 0. So the gradient is 2.5. So the gradient of the speed time graph representing rate of change of speed. And if the gradient is positive, it means the car is accelerates at the rate of 2.5 acceleration. Okay, for the first 10 seconds. Question B. What happens to the motion of Mr. Daniel Wong's car from 10 seconds till the 20 seconds? So, Mr. Daniel Wong's car moved at a uniform speed of 25 meters per second from the 10th second until the 20th second. So the keyword is uniform speed. Uniform speed. Right? The purple color line show that the line is horizontal. So this show that Mr. Daniel Wong's car moved at uniform speed of 25 meters per second. From the graph, you can see 25 meters per second for the horizontal line. C. Calculate the rate of change of speed in meter per second for last 5 seconds. So for the line CD, let's say the point is C and D. So the point D is 35, 0 and point C is 20, 25. So if you use a gradient formula, okay, the y2 is 25, y1 is 0. Okay, y2 minus y1, 25 minus 0, over x2 minus x1, which is 20 minus 35. So your answer is negative 5 over 3. So the rate of change in speed for the last 5 seconds and for the last 15 seconds are the same. The rate of change in the speed for the last 5 seconds and the last 15 seconds are the same because they are having the same gradient. Alright? Question D. Calculate the distance in meters traveled during the deceleration and describe the motion of the cars for the period. So the deceleration happened for the last 15 seconds. So we need to find the distance traveled. So the distance traveled is area under the blue line. Okay, so you'll find the area for the triangle which is 1 over 2 times the base. The base is 35 minus 20 times by the height of the triangle. So the answer is 187.5. Okay, 187.5. The height of triangle is 25 and the base of triangle is 15. So the distance traveled during the deceleration time is 187.5 in 15 seconds with deceleration of 5 over 3 meter per second per second. Again, to describe the motion, you need to use the keywords. The car travels of 187.5 meter in 15 seconds with a deceleration of 5 over 3 meter per second per second. Must write in a sentence with the right information. There are 3 information. One is distance and the time and the deceleration. Okay, so when you write deceleration, you cannot put negative because the D itself, it means negative. Okay, so deceleration of 5 over 3 meter per second is actually equal to negative 5 over 3 meter per second per second. Okay. Let's see example 2. The speed time graph shows the motion of one Selena's car for a period of 15 seconds. So A, calculate the rate of change of speed in meter per second for the first 5 seconds. So to find the rate of change, we will find the gradient for the line which is in orange color. So we label as point A 0.20 and point B is 5.40. Then we will find the gradient. Take 40, which is your y2, minus 20, which is your y1, over x2, which is your 5, minus x1, which is 0. Okay, so the gradient is equivalent to rate of change of speed, which is positive 4 meter per second per second. So the car is accelerates with a 4 meter per second per second. Question B. Describe the motion of the car for the second 5 seconds. So as you can see from diagram, the car moves at uniform speed of 40 meter per second for period 5 seconds. For question C, calculate the total distance in meter traveled in the period of 15 seconds. So total distance means area under the graph. So for the area number 1 is 1 over 2 times 5 times 20 plus 40. This is a trapezium. For area number 2, this is a rectangle. So the length is 10 minus 5 and the width is 40. Okay, and finally the area for number 3 is another trapezium. So it's 1 over 2 times 15 minus 10 times 40 plus 60. Okay, so the area for number 1 is 150. For number 2 is 200. And area for number 3 is 250. So the total distance traveled is equivalent to 150 plus 200 plus 250. So the total distance is 600 meters. So to all the students, I hope you understand how to interpret the speed time graph. No problem. So now I would like to give you some homework to do. Self-practice 7.2D. Question 1. 2, and 3 at page 205. Okay, students, before I end the class, I will try to discuss with you how to solve question 1, 2, and 3. Please follow my video. So let's discuss question number 1. The speed time graph shows the motion of a motorcycle for a period of 50 seconds. Describe the motion of the motorcycle for the first 20 seconds. So the speed of motorcycle decreases from 35 meter per second to 20 meter per second in 20 seconds. And the speed is 35 meter per second beginning, decrease to 20 meter per second. Or we can use a gradient method. So for the straight line, which is in red color, first of all we label the point 0, 35 and 20, 20. Then we find the gradient using the formula y2 minus y1 over x2 minus x1. So hence the answer is negative 0.75. The negative representing deceleration. So the motorcycle is decelerating at 0.75 meter per second in 20 seconds. So please do not write negative because the word decelerating represents negative. So now we need to find the distance for the area under the line. So the area under the red line there is shaded in yellow color. So we need to find the area using formula of trapezium. So it's 1 over 2 times 35 plus 20 and times the height of the trapezium, which is 20. So the answer is 550 meter. So the motorcycle moved 550 meter in 20 seconds. This is so-called describe the motion. For question B, we need to describe the motion of the motorcycle at a uniform speed. So uniform speed is the line in blue color. So the time is between 20 to 50 and the line is horizontal line. So we need to find the area under the straight line, which is a rectangle shape in yellow color. So 50 minus 20. So for part B, we need to find the area under the blue line, which is 30 times 20, rectangle. So length times width, so it's 600 meters. So the motorcycle is actually move or travel for 600 meters. Okay, now we will continue to question number 2. The speed time graph shows the motion of a particle for a period of 18 seconds. Calculate the acceleration in meter per second of the particle for the last 6 seconds. Okay, so acceleration here, when you see acceleration, please highlight. And when you want to find acceleration, actually it means that you have to find the gradient for the 6 second. Last 6 second. Okay, so please highlight the part of the line in blue color. So the last 6 second, and after you color, you label the point 12, 15, 18, 20. So then you just find the gradient for the blue line, and the gradient is 5/6 meter per second per second. Remember, ms -2. Okay, for acceleration or deceleration, the unit is meter per second per second. Okay, question B. Calculate a total distance in meter traveled by the particle for a period of 18 seconds. Okay, highlight total distance. The keyword is total distance is equal to area under the graph. Okay, area under the graph. For the period of 18 seconds, so now we need to find the total area for the line. Okay, so we have trapezium in yellow. So the area for trapezium is 1/2 plus 15 times 5. Okay, then we have to find the area for rectangle, 15 times 7. Then followed by, we need to find the area for the trapezium in purple color. Is 1/2 times 15 plus 20. This is 15. This is 20 times the height, which is 18 minus 12, 6. Okay, so total is 260 meter. So next, question C. Describe the motion of the particle when it moves at a uniform speed. Uniform speed means the horizontal part. So it happened at 15 seconds. So the time is from 5 seconds to 12 seconds. So the particle moves at a uniform speed of 15 meter per second in 7 seconds. 7 seconds, okay? 5 to 12, which is 7 seconds. So you need to write in a complete sentence. Okay, next we go to question number 3. Inje Marisha visit his friend who live in the same housing estate by car. The speed time graph shows the journey of Inje Marisha to his friend's house. A. Calculate the rate of change of speed. Please highlight in meter per second of his car for the first 20 seconds. Now for A, rate of change of speed. Okay, rate of change of speed meaning that you need to find the gradient for the first 20 seconds. So let's go to diagram and draw a line about 20 seconds. Okay, that is the part at 20 seconds. So we need to find the gradient for this part of the line. So the gradient for the 0 to 20 seconds is highlighted in blue color. Okay, we want to find the gradient, but actually we don't have the point, so we just find the gradient for the one whole straight line. Alright, because all the points on the straight line are having the same gradient. So it's actually 15 minus 0 over 40 minus 0. So the gradient for the line that I highlight in black color is 3/8, and the gradient representing rate of change. So please write your unit properly, 3/8 meter per second per second. Okay, for part B, calculate the distance again. Okay, distance means area in meter, travel at a uniform speed. So we need to find the area for the line, which is in blue color. So the area is a rectangle shape. A rectangle shape with the length and the width. So 120 minus 40 times the length 15. So the answer is 1200 meter. Now we will discuss part C. Okay, describe Inje Marisa's journey for the period of 2.5 minutes. Okay, so when describe journey, we need to have total distance. For 2.5 minutes, so we have to convert to how many seconds? 2.5 times 60, so it's 150 seconds. Right, so we need to find the area for the whole journey. That means we need to find the area representing distance. Okay, so when describe for the journey, we need to have the total distance and total time taken. And then we need to find the average speed for the whole journey, and we need to write in a sentence. Okay, now we want to find the area for the whole diagram. So distance for 2.5 minutes is equal to area under the whole graph. So 102 times 150 plus 80. Okay, that is the 150. 80 is the upper part, 80. Okay, and the height is 15. So half A plus B times the height is 15. The height is in red color. So distance is 1725 meter. Okay, so with the distance traveled and the total time taken for 150 seconds, we can find the average speed. Remember the formula, total distance over total time taken is a formula for average speed. So 1.725 over 2.5 over 60, because the question is asking for kilometer per hour. So the conversion of unit is very important. So the answer is 41.4 kilometer per hour. Okay, this is the average speed. So let's write our sentence. Inje Marisa drive for a distance of 1.725 kilometer for 2.5 minutes, with an average speed of 41.4 kilometer per hour. To all the students, I hope now you have a clearer picture how to interpret the speed time graph. Okay, I also hope that you will know how to solve the problem given. So have a nice day. Bye.